Hello, mathematicians. Welcome to another lesson. This is Mr. Garcia, and today's lesson is 8.3, talking about inscribed angles. So let's take a look at our objective. I can find the measures of angles inscribed in a circle. So this word here, inscribed, we never really talked about what it means. We've heard it before, but inscribed basically means that I have something, a shape, an angle, anything that is inside of a circle. So anything that I draw that is completely inside is inscribed in a circle. So take an example here. I have a circle, and if I were to inscribe this triangle, I can see that each vertex is on the circumference of the circle, and the shape itself is all inside of the circle. So this is an inscribed triangle. But today we're going to be looking at just the angles, but how we can also use these to form different shapes and find different angle measures of each one. We're going to see the relationship between arc measures and inscribed angles. So let's go ahead and start by reviewing what an inscribed angle is. We talked about the definition before in lesson 8.1, but we're going to review real quick. An inscribed angle is made up of two chords. It could also be two secants with at least one of the chords or secant that doesn't pass through the center. For example, here, both of the red lines, neither of them pass through the center, and that's okay. At least one can pass through the center, and that's also okay. But we can't have both going through the center because that wouldn't be an inscribed angle. So as long as one is not through the center, then we're good to go. Now, two chords or two secants can create an inscribed angle if the vertex is on the circumference of the circle. So in this case, my vertex is point B. And I can see how this angle comes this way. So here's my vertex, and you can see that it's on the circumference of the circle. The other two endpoints are also on the circumference. They don't have to be. They can extend out more if you want. But that vertex has to be on the circle. That's what makes this an inscribed angle. Now let's talk about the relationship between an inscribed angle and the arc. Here is our first rule for inscribed angles. The measure of an inscribed angle is half the measure of its corresponding arc. So the measure of an inscribed angle is half the measure of its corresponding arc. Now you can make a little song about this. You can create some kind of mnemonic device, something to help you remember. Inscribed angle is half the arc, or something like that. I like being silly. Y'all know that. So either way, what's important to remember here is that the measure of an inscribed angle is half the measure of its arc. Take a look at the circle here, and I'm going to demonstrate how this is true. So I'm going to take my protractor here, and I want to measure this angle. So here is my line here, and I can see that my angle is 30 degrees. So I'm going to write down here that the angle measures 30 degrees. This is angle DBC. Now I want to measure the arc now. Remember that there's no easy way to measure an arc itself, but we know that the central angle that corresponds to that arc has the same measure as the arc. So if I create a central angle like this one, angle DAC, I can measure that angle and it'll give me the measure of the arc. So let's do that. I got my protractor back. I'm going to put my center over point A. So I got my protractor here. I'm going to rotate that a little too far. Right there, perfect. And we see that that angle is 60 degrees. Let me get this out of the way. And I'm going to write 60 with my pen in blue. So we can see that the measure of the angle DBC, measure of angle DBC is equal to 1/2 the measure of angle DAC. So if I remember that the inscribed angle is half the measure of the arc, then the converse is also true. If I have an arc and I know its measurement, if I divide that by 2, that will give me the measure of an inscribed angle. Now, is that for any inscribed angle? That's actually going to go into our next point. Rule number 2 for inscribed angles says that inscribed angles with the same corresponding arc have the same measure. So if I have these 3 angles, EDF, ECF, and EBF, these are all inscribed angles because all of their vertices are on the circumference, and they all have the same endpoint. So they all intercept the same arc. Now I'm not going to bother measuring the arc here because I already know from the first rule that the inscribed angle is half the arc. So if I can find the measure of one of these inscribed angles, then I'll know the measure of the arc because I can multiply it by 2. So let's check. If I take my ruler, my compass, protractor, sorry. And I measure that angle, seems to be 50 degrees. So I'm going to move this out of the way, and I'm going to put 50 degrees. Which means that the arc, since the arc is twice the measure of the inscribed angle, the arc should measure 100 degrees. But we have multiple inscribed angles here. So let's see if it's true. If inscribed angles with the same arc have the same measure. So here I measure this angle, which is also 50 degrees. Let me write that here. And finally, we have our last angle up here, the green one. If I measure this angle, it is also 50 degrees. It's not perfectly on the line here, and it doesn't want to get on the line, but oh, there we go. Yep, 50 degrees. Perfect. So any inscribed angles that share the same arc are always going to have the same measurement as well. That doesn't mean that they're congruent. If they were congruent, then the lines of the angle would be exactly the same as well. But it just means that they all have the same measurement because they all share the same arc. Now that we know the 2 rules for our inscribed angles, let's put them to work. We're going to go through a couple of examples and use these rules to help find some missing measurements. Let's go to number 1 first. Here I have a circle, and I'm looking for the measure of angle KJM, the measure of arc JM, and the measure of angle JKL. So let's start with the measure of angle JKM. And I'm going to highlight that in red, and everything I'm going to do over here with JKM is going to be in red as well. So I'm starting with point K, then going to J, then going to M. And this is an angle, so I'm going to follow the line. So here's point K to point J, and I'm going to go down to point M. And so what I'm looking for here is the measure of the angle. Now, I already know that this is an inscribed angle since I see that point J is on the circumference and it's also the vertex of my angle. So I need to find then what is the measure of this angle. Now, I don't know anything else. I see a 53 here, but that doesn't have anything to do with this angle. I see a 20 degrees down here, but again, it doesn't do anything with this angle. So now I'm kind of stuck. Well, let's take a look at this line here. You see that K segment KM goes through the center. It goes through point A. I have a chord that goes through the center of my circle, which means that this line KM, this segment KM, is a diameter. Now we need to be able to recognize those things. So if you still have trouble identifying some of these parts and their significance, go back to lesson 8.1 so you can look at those parts of the circle again. But knowing that this is a diameter tells me that this arc out here, which I'm going to outline in purple, having that diameter tells me that this arc KLM is a semicircle because a diameter cuts a circle in half, right? So this must be a semicircle because it's half the circle. And if a complete circle is 360 degrees, then a semicircle must be 180. So I know that the arc here measures 180 degrees because I have the diameter here, KM, which happens to be the endpoints of my angle as well. So knowing that the arc is 180 degrees, let's go back to rule number 1, which tells us the measure of the inscribed angle is half the measure of its arc. Inscribed angle is half the arc. I just like to memorize things that way, but it helps. Inscribed angle is half the arc. So therefore, if the arc is 180, then I divide 180 in half, which gives me 90. Therefore, angle KJM must be 90 degrees. So remember, keep an eye out for those diameters because those diameters are telling you there's a semicircle somewhere. And we know that a semicircle measures 180 degrees. And that'll be helpful in finding some of these inscribed angles. Let's move on to the measure of arc JM. So I'm going to do that one in green. So the measure of arc JM, let's go find it. So here's point J, here's point M. I know it's an arc and it's a minor arc because there's only 2 letters. So I'm going to highlight this piece right here. So I'm finding the measure of the arc. So let's take a look around to see if there's anything that can help us. I already did this part with the 90 degrees here. Now that's not really going to help me in this case though. So I'm actually going to erase this to get it out of the way. Since it's not going to help me right now, I don't need it. Besides, I already know it because I already wrote it down. So if I do need it, then I can go back and draw it in again. I'm going to erase this part too since I also don't need that. And I know I don't need it because the only arc I'm concerned with is the one right here. So now that I have this arc isolated, let's take a look and see if I can find anything, any measures or any numbers relating to that arc. So I know it starts at point M, point J. So what if I follow these back? And I see that there's an angle here, and I'm given the measure for that angle, which is 53 degrees. So remember, inscribed angle is half the arc. So that means that since the angle is 53 degrees, some number over here was divided by 2 to get that 53. So if I want to find that, then I can work backwards. Instead of dividing, I'm going to multiply 53 times 2. And what that gives me is 106. So here, I know that the arc measures 106 degrees. And I can double check this because I know that if I divide 106 by 2, since that's the measure of the arc, that should give me the measure of the inscribed angle. So 106 divided by 2 gives me 53, so I'm good to go. And always double check your work so you know you're doing it right, so you know you have some way to verify if you're right or you messed up somewhere. Finally, let's move on to the last one. I think I'm going to do this in blue. We're looking for the measure of angle JKL now. So let's highlight JKL, see where that angle is at. So here's point J, here's point K, and then down here is point L. So I have J, K, and L. J, K, L. So there's my angle here. Now, if you notice, this angle JKL also uses the 53 from earlier. So we're going to keep those highlighted because those might help us here. So let's take a look at what we have then. We know that this arc is 106 degrees. We see this arc down here, arc ML, is 20 degrees. We know that angle JKM is 53 degrees. If I were to add these two angles here, the 53 and this angle MKL, then I could find what the measure of JKL is because I'll add them together. They combine to make one angle. So the trick is that since I know the arc is 20 degrees, and I know that MKL is an inscribed angle, and I'm going to highlight it in pink so we can take a look at this. Since I know MKL, that arc measures 20 degrees. So since inscribed angle is half the arc, 20 degrees divided by 2 is 10. So this arc, this angle, MKL measures 10 degrees. So now if I add these two together, 53 plus 10 gives me 63. So that means that angle JKL must measure 63 degrees. Now, if I want to find a way to check that, remember that I can also combine these arcs to get a total arc measure. So if I add the 106 with 20, that's 126 degrees. Now, since angle JKL intersects arc JL, and arc JL measures 126 degrees, then the measure of JKL is the arc measure divided by 2. And if I divide this by 2, it gives me 63 degrees. So that's one way to check then. If everything, the math goes well, and the arc measure is half the inscribed angle, then we're good to go. All right, so that was an easy example, or not easy, but a little more straightforward. Let's take a look at a little more advanced example now. This example is not necessary for regular geometry. So if you're in a regular geometry class, you don't really need to go through this. You can still watch it. Obviously, you're free to look at it if you want to learn a little bit more. But pre-AP and dual language, you're going to have an example like this in your homework. So it might be a good idea to watch this example. Regulars, you can stop here, go back if you need to, or go watch Miss Caddy's video for more additional help if you need it. So let's take a look at this one. So example number 2, we have 4 things that we're looking for. We're looking for x, the measure of angle QRS, the measure of angle RST, and the measure of angle STQ. What we have here is a quadrilateral. It looks like a rectangle, but since these angles aren't marked 90, it's not a rectangle. We can't assume that. So we have a quadrilateral here. We do have one 90-degree angle, but we need to find basically every angle of this quadrilateral using the information we're already provided. So why don't we start by finding x first? And I'm going to do this in red. So to find x, there's a couple strategies that we can use here. First of all, if you remember from our last video, the sum of all of the arcs measures of a circle always add up to 360 degrees, right? Which means that if I combine all of these into a single equation and solve it, then I can find the measure or whatever x is here. So let's try that. I'm going to start with x over here. So I have x, and I'm going to add everything else. So then I have plus 2x plus 9, which comes from over here, and then plus 67, then plus 128. And all of these add up to 360 degrees. So now I can combine my like terms. See, I have my variables here. I'm going to draw a square around them. I have my constants over here. I'm going to circle them. And now I need to combine them. So x plus 2x gives me 3x. Then 9 plus 67 plus 128. I can't do that in my head, so let's plug that in. You get 204. And then equals 360. So now I need to solve this. I'm going to start by canceling out the constant here since I already have the variables all on the left-hand side. I'm going to cancel out 204 by doing the opposite of plus, which is minus. Whatever I do on one side, I do to both. So this cancels out. And I'm left with 3x on this side equals, and I don't know what that is, 360 minus 204. Ooh, let me try that again. 156. And finally, to get rid of the 3, I divide by 3. So 156 divided by 3 is 52. So x here is 52. Excellent. So let's move on to the next part. I'm going to clear this out at the bottom so that I have some more space to work with. What we're going to look for next is the measure of angle QRS. So let's go and highlight that angle. We're going to start at point Q, go to R, then finish at S. So we start at point Q, we go to point R, then S. So to find this angle, if we look, we don't really see anything obvious here that can really help us out. But we do notice that our arcs, intercepted arcs, corresponding arcs, is this one right here. So if I know the measure of that arc, and I divide that by 2, then I can find the measure of the angle here. Now this arc, though, is made up of 2 pieces. We can see that one piece is the x, and the other piece is 2x plus 9. So all I have to do is add these 2 together, and then I can find the measure of that arc, and then divide that measure by 2 to get the measure of the inscribed angle. And since I know what x is, I can substitute those in. So instead of this being x, how about we substitute 52 degrees? 2x plus 9, if I plug that into my calculator, 2 times 52 plus 9 gives me 113. So instead of being 2x plus 9, now I know that that can also be 113 degrees. So now it's a little bit simpler because all I have to do is add these 2. 113 plus 52. I add those 2 together. That's 5. 165 degrees. But I made a mistake. Did you catch it? I hope you did. This is the measure of the arc, right? This is the total measure of the arc. But it's not necessarily the measure of the angle, because remember, the inscribed angle is half the arc. So I need to divide this by 2 then. So 165 divided by 2, so that's 8. So 82.5. All right, so let's move on to the next one. And I'm going to clear what I don't need, so I'll be right back. So the next thing that we're looking for is the measure of angle RST. So let's take a look at RST now. RST. And again, it looks like we have two different arcs that we need to combine. So we can divide that by 2 and get the measure of the inscribed angle. So let's add these two together. 128 plus 52. That gives me 180. So 128 plus 52, and I'll write it down. Now, in order to find the measure of the inscribed angle, then I need to take my 180 and divide that by 2, which gives me 90. So the measure of angle RST is 90 degrees. So here I have another right angle. It just wasn't marked as such, but now I know that that is also a right angle. All right, so let me clear this and we'll come back. So the last thing that we need is the measure of angle STQ, which I'll highlight in pink. Let's take a look. S is here, T is over here, and Q is here. And so again, it just looks like we just need to add 2 arc measures and divide that by 2 to get our missing angle. So let's do that. So 128 is my first arc up here, plus 67. And remember, I'm adding these because if I'm looking for the measure of the inscribed angle, my arc is starting at point Q and going past point R, and it finishes at point S. Because this arc is QS over here, or QRS, and it's broken up into 2 pieces, then I'm adding those 2 pieces so that I can get the total arc measure for QRS. And once I know that, then that'll help me find the measure of the inscribed angle. So these two added together is 195. Again, that's the measure of the arc, but to find the measure of the inscribed angle, I need to divide that by 2. So I get 97.5 degrees. And there we go. So if you need some more advice, I suggest you watch Miss Caddy's video or go back, because I know this topic is a little bit more confusing than other stuff that we've done with circles so far. But you have this video, you have Miss Caddy's video, and you can always contact us by tutoring, attending those Zoom tutoring sessions that we have posted. We don't get a lot of people there, so it would be nice to see more students show up when they need help. All right, so don't be shy, come by, ask us for help. All right, so with that said, that concludes this lesson. Go ahead and go look at your assignment. Remember, if you have questions, please feel free to reach out to us. Have a great time, have a great day, and I'll see you guys later.